Atoms, they make almost everything in the world. But what are their properties in BFDI? There are 4 times that we see atoms in the show. The first one is in BFDI 3, but the atom just looks like a dot, so we can't do anything with it. The second one is in BFDI 5, where we see 2 atoms undergoing nuclear fusion inside needles cake starting. The third one is in BFDIA 15, where the characters get shrunk to the atomic level and remove protons from lead atoms to make thallium, mercury, and gold. The fourth one is in BFDIA 16, where the contestants interact more with gold atoms from the previous episode. We also see 2 gold atoms fusing, which causes a big explosion. There is also this scene in Teapot 3, but I will get to that later. First, let's measure subatomic particles. Since in BFDI 15, we see the characters get shrunk, we can follow a character from the start of the episode until the end, keeping track of their size. I will use Fry's since we already know his size from last episode. When a character gets shrunk, the camera often changes zoom, so we need to account for that. To calculate the change in zoom of the camera, we can use a length with fixed size. But L1 be the length before the change in zoom, and L2 the same length after the change in zoom. The zoom z is given by L1 divided by L2. If z is greater than 1, the camera zoomed out, and if z is less than 1, the camera zoomed in. Then, to calculate the size of shrunk fries, we can modify the length formula from last episode by multiplying it by the zoom change. So we get this formula. With this, we can follow fries from normal size to the atomic level. Then we can measure subatomic particles. The protons and electrons in this frame have a radius of 3 times 10 to the minus 8 meters, while neutrons have a radius of 2.28 times 10 to the minus 8 meters. However, these particles come from the birdhouse that was shrunk 2 times before entering the water drop where the contestants are. We also can't see individual atoms in Boog's gold metal. This means that the shrink ray makes atoms smaller, so we need to account for that. By analyzing the video, we see that the birdhouse was shrunk by a factor of 17 times, so the unshrunk protons and electrons have a radius of 5.1 times 10 to the minus 7 meters, while protons have a radius of 3.88 times 10 to the minus 7 meters. For comparison, a proton in the real world has a radius that is measured to be between 8.77 times 10 to the minus 16 meters and 8.42 times 10 to the minus 16 meters. Neutrons have a radius of 0.8 times 10 to the minus 15 meters, and the classical electron radius is 2.82 times 10 to the minus 15 meters. So subatomic particles in BFDI are much larger than subatomic particles in real life. But this is not the only difference between atoms in real life and in a shell. We also see that shells are physical things that the electrons are attached to and aren't just the positions that an electron can take. We see contestants removing protons from the atoms, changing the element. However, after removing a proton, the number of electrons and protons also changes. Assuming neutrons or electrons have mass, this means that the conservation of mass is not true. The protons also don't appear to have any repulsive force between them. So either they don't have charge, or electromagnetism works differently. Either way, this completely changes chemistry, since atoms form bonds and exist at all due to electromagnetism. But the breaking of laws of physics doesn't stop there. It also breaks the Heisenberg uncertainty principle, that says that the uncertainty of position, delta x, times the uncertainty of momentum, delta p, of a particle is greater than or equal to h bar over 2. But electrons are particles and we know exactly their position since we can see them. So delta x times delta p is equal to 0, which is less than h bar over 2. There are also other weird things. In the next episode, we see Nico using a gold atom like a trampoline, so these atoms can squish. We also see that both the shells and the electron collide with the contestant. We also see that combining two gold atoms releases enough energy to make the water drop jump to the wall. In BFDI 5, we also see that two hydrogen 2 atoms combine to make a helium 4 atom inside Needle's cake star, which is not what happens in stars in the real world. We also see that characters die when they touch a lead atom or a proton. However, Book didn't die when they touched the lead paint in the bird's house. Another thing to note is that we don't necessarily see all the protons and neutrons in an atom, since they could be behind other particles. Now, regarding the teapot tree scene, I don't think these are atoms, since what we see here is nothing like the atoms in BFDI 5 and BFDI 15 and 16. If anything, it looks like a neutron and two protons, making some charged thing that is kept in place by the snow, but it could be something else that just looks like a neutron and two protons. Here is my attempt at explaining this. An atom is made out of two parts, the nucleus and the electron cloud, each one made out of two things. The nucleus is in the middle of the atom and is made out of protons and neutrons. The electron cloud is in the outside of the atom and is made out of electrons that are attached to shells. Electrons have negative charge while neutrons have positive charge. Protons don't have charge. A particle's charge increases with its volume, so if you change the size of a particle with the growth of shrink rate, its charge will change. When a proton is removed from the atom, the number of neutrons, electrons, and maybe shells is changed, such that the atom is in a more stable configuration, releasing energy. The energy release grows exponentially with the number of particles that were added or removed. So if a single proton is removed, the amount of energy released is small, but if two atoms with a lot of particles are combined, while combining two gold atoms, a macroscopic amount of energy is released, enough to make a water drop jump a few centimeters. Electrons in lead, thallium, and mercury atoms can interact with electrons in other atoms, so getting close to one creates a charge that changes the stability of other atoms. This causes the atoms to change to a new element to cause a new stable state, killing the person. If protons have high speed, they also change the most stable configuration of an atom, so getting hit by one has a similar effect to getting close to lead. Oh, and the shows are bouncy for some reason. I think this theory explains everything we see about atoms in the show, but I might have missed something. If you saw something that can't be explained by my theory, please put it in the comments. Before I end the video, I would like to say that since neutrons have positive charge, it doesn't make sense to call them neutrons. So if you have an idea of what to call them, please also put them in the comments. This is all I have for this video. Goodbye.